Okay, hi BC. Congratulations on finishing your test today. This screencast is part of your homework. It'll be very short and sweet. The topic here is definite integration involving substitution. If you look here at the example that I gave here, this is an indefinite integral, once again, because there are no limits of integration. Okay, and we know how to take care of this indefinite integral using u sub. The topic of this screencast, though, and the reason why this is new for you all, not the AB folks, but you all, is we're talking about definite integration involving u sub. And there's a very important distinction here. One, we have to remember that definite integration is going to result in a number. That number represents the net signed area bounded by this function, the integrand, over the interval x equals 1 to x equals 2. However, what I pay very particular attention to when we work with a definite integral involving substitution is the attention you place on the relationship between the dummy in this question and everything else. Let's begin. So right here, this definite integral is in terms of x. The dummy is dx, the variable of integration is x, and also, and possibly most importantly for this topic here, is that the limits of integration are also in terms of x. I mean, I've even seen some textbooks that have x equals 1 to x equals 2. I mean, they even write the x equal with the lower limit of integration and the upper limit of integration. I don't know when that ended up being dropped as a habit, but the point here is that this dummy, the dx, tells you a lot of things. And I already talked to you about some of those. The new detail with the dummy is that it also specifies that if the dummy is dx, it specifies the nature of the limits of integration, and specifically that we're looking at the interval of x from 1 to 2. Okay, when we go about evaluating this definite integral, let's deal with the process of anti-differentiating first. This is not going to be new to you, because if you were dealing with the indefinite integral, you would go ahead and let u equal 4x minus 2, and then you do this, du by dx equals 4, or du equals 4 dx. You see that? And some of you then will go and say that du over 4 equals dx. What this substitution does is it allows you to then rewrite the indefinite integral as 1/4 u cubed du. Okay, and now notice something. What I've gotten here is an indefinite integral that is simpler. The question, though, is how do I take the limits of integration that were in terms of x and change those limits of integration in terms of x into limits of integration here that need to be in terms of what? Yes, u. They have to be in terms of u. Well, the key is in here. The key is this statement. The relationship between x and u is stated in this statement right here. U equals 4x minus 2. So then we're going to say, well, when x equals 1 corresponds to the u valuing being 2. So x equals 1 being the lower limit in the integral with respect to x becomes u equals 2 in the integral with respect to u. By similar logic, when x equals 2, the upper limit of integration in the integral in terms of x, when x equals 2, u will then equal 6, and there is my upper limit of integration. So if I can just rewrite this without that box interfering with my eyes, I have this. Okay, now what we can say is that these two definite integrals, this definite integral and this definite integral, is now equivalent. I will show you the most common error that I see, and it looks like this. Okay, in the course of working through a definite integral that involves substitution, I will often see people doing this. They will very kind of quickly and cavalierly go here and put the lower limits to be 1 to 2. What are they doing? They're just replacing these limits of integration and putting them into this definite integral. And that is absolutely wrong, because this definite integral is no longer in terms of x, it needs to be in terms of u. If the integral is in terms of u, then so must the limits of integration. That is the single most common mistake. Let me get this blasphemy corrected. So once again, this should be, did I say 2 to 6? Yes, 2 to 6 of 1/4 u cubed du. Okay? And of course now I'm just going to evaluate this definite integral. And what I get is 1/16 u to the 4th evaluated from u equals 2 to u equals 6. And I do get 1/16 times 6 to the 4th minus 1/16 times 2 to the 4th. I can just do this actually. And there is my net signed area, okay? So when we're dealing with definite integration that involves u substitution, you have to be mindful of rewriting the limits. Let me show you another way that I've seen people do these kinds of definite integrals. Some people like to do this. They will come over here, like put the original one up there. Is it 1 to 2? Is that right? It was? Yes. Okay. They'll come down here and do this. They will choose to do this. They will say, I'm going to first recognize this question is a definite integral question, but I'm first going to take care of the indefinite integral first. This is what they do. They do this, and they say, okay, let's deal with the indefinite integral. Let u equal 4x minus 2, du equals 4 dx. This then, when I take this and sub back in, what this allows me to get is the indefinite integral of 1/4 u to the 4th, which then equals 1/16, 1/4 u cubed, pardon me, 1/16 u to the 4th, which is the same thing as 1/16. And here's what they do. They will take this u and they put it back in, just like you did when you first dealt with indefinite integrals involving u sub. And then what they'll do is this. They'll say, okay, I know this question is an indefinite integral. Sorry, the question was a definite integral initially, right here. What I did was I evaluated the indefinite integral, and I evaluated the indefinite integral in terms of x, and then what they do is they bring it back to the definite integral question. They'll say this, the definite integral from 1 to 2 of 4x minus 2 cubed dx, therefore will equal, and there's that indefinite integral, 1/16 times the quantity 4x minus 2 all to the 4th, evaluated now from 1 to 2, okay? And then what they do is just go ahead and just plug and chug, right? So I will say that some people like to just evaluate the limits of integration in terms of the original variable that the problem was given to them in, because I don't know, they may have a fear of losing track of the u or something. The choice really is yours. I will tell you this, generally speaking, and again, no rule in calculus works 100% of the time, but I will share with you this. Generally speaking, the method up top here ends up being a little bit easier because while you do have to think about this, the changing of the limits of integration, the inputting in of the lower and upper limits of integration and using the fundamental theorem of calculus part 1 ends up just being arithmetically easier in this version. And even if you look at this here, like look what you're plugging 6 into here versus plugging 2 into here. You know what I mean? So again, this is where you have a choice. It really is up to you. But I will tell you that given your two options, I generally tend toward option 1, taking a definite integral, rewriting it entirely in terms of u, including the limits. Okay? Let's just make sure we're all on the same page, and then I'll just let you start your homework. Okay? Why don't we try this one? Let's take a look at the definite integral from 1 to root 2 of x e to the negative x squared dx. Go ahead and try that on your own, and then replay me for your listening and answer verification pleasure. All right, here's the answer. Some of you just like to see the answer. So there's my answer right here. Okay, but here's my work all the way through. And there you go. All right, look at that. 10-minute screencast, not bad. Oops, sorry, you can't see that clock. All right, everyone, have a wonderful evening. Bye.